right, here we go. Here we are going to continue doing our notes from yesterday. Again, we are doing radical notes. It's going to be a radical time. For real. All right. So you wanted to, as your warm-up, finish the practice problems. The practice problems from yesterday. Let's see here. Or don't do that. So if you remember from yesterday, we did these. So we should have already, on our paper, have 3, 4, and 5. You want to make sure you've done 1, 2, and 6. Okay? And then on the next page, we did these examples. And you want to make sure... Sorry, it's whatever. All right, so make sure you've done those practice problems. Okay, so here we are today. We are going to talk about division of radicals. So yesterday we did multiplication. Today we're doing division. I'll be honest, some people get confused on division, so you want to make sure you're following along very closely. And you got your notes in front of you without your headphones in and no movies on and other silly things. So here we go. By the way, if you notice, this Roman numeral for 4 should be IV. And I guess I had to recalibrate. Here we go. IV. So that's really 4, okay? Maybe yours already said that. Whatever. All right, so division of radicals. It's actually kind of simple like multiplication. Outside with outside, inside with inside, okay? So check it out. When dividing radicals, you must divide out the numbers outside the radicals and then divide the numbers on the inside of the radical. So let's just do it out and then in. So on the outside, so I got 4 divided by 2. Okay, 4 over 2 gives me 2, right? So you're just dividing. 15 and 3 are on the inside, so now we're going to divide those inside the square root. What's 15 divided by 3? 5. Now let's think. We always want to think, can I reduce that radical? So can we reduce 5 any further? We can't because 5 is a prime number. Good. So 2 square root of 5, that's it. All right? Was that hard? Maybe not. Okay. Over here, outside of 6 and 2. So 6 divided by 2 is 3. And then on the inside, square root of 10 over square root of 5. What's 10 divided by 5? 2. Can I break down 2? No. So that's 3 square root of 2. Okay. So you can try these 2 problems right here. I'll give you like a minute or two. I want you to remember, if there's no number in front, what number goes there? So this right here is a little 1. Okay. So let's see what you got. Give you like a couple minutes. All right, so let's see what we got. 8 over 1. What is 8 divided by 1?
1, 8.
Just 8, okay? So we put 8 right here. And then 4 divided by 2 gives me 2 is 2 prime. Yes, it's prime, so no, we cannot break it down. So 8 square root of 2 is my final answer, right? Everyone with me? Number 2, 2 over 2 gives me what? 1. Now you can write 1, and then square root of 4 over square root of 2 is 2. 4 divided by 2, 2. But normally you don't see a 1 out in front. So typically it would be just square root of 2. Okay? Okay? We good so far? So let's go to Roman numeral 5. Okay? Rationalizing the denominator. This is probably the most challenging part of this stuff. It can be confusing, but we're going to make it as simple as we can, right? Because we're going to keep everything 1 to 2 steps, right, Miss Moreau? Simple steps, and but we're still going to have rigor at the same time, right? And try not to have rigor mortis. All right. V, rationalizing the denominator. Should a radical appear in the denominator of a fraction, it will need to be removed. So if you see a radical on the denominator, which way is the denominator? Down. Denominator? Down, right? So on the bottom, however you want to call it, if you see it on the bottom, it needs to be removed. Okay? So how do we remove it? That's what I'm going to show you. How do you take out that square root sign? Okay? So to remove a radical from the denominator, we're going to multiply the numerator and the denominator, both top and bottom, by the same radical. This will create a perfect square radical in the denominator, and I'll show you how it works right now. So if that didn't make sense, watch and see. Okay? I look at number 7. I look at the bottom. I see a square root on the bottom. This is one of those mathematical no-nos. No, 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 no. Miss Merrill.
No. What are we doing here? No. Shake your geometry.
Thank you. All right. That's Lori and the Sunshine Band, right? All right. So if you have a square root on bottom, that's a no-no. So what do? Like it says up top, we're going to multiply by the same square root. So I'll say it again. You're going to multiply by the same square root. So on the bottom, I'm going to put times, and then I'm going to write the exact same square root. But if you do it on the bottom of the fraction, you're also going to do it on the top of the fraction to keep it even. So it's going to be times square root of 3 on top. Okay? So on top, 2 times the square root of 3. It's not 6. It's not square root of 6. Okay? Whenever you have a number and a square root, they're different things. You're just going to put them next to each other. Okay? So 2 square root of 3 is 2 square root of 3. Every time you have a regular old number and a square root sign number, just put them next to each other. So we have 2 square root of 3. Okay? Now on the bottom, I want you to go back in time yesterday and tell me what we learned down here. Okay? So if you remember yesterday on Roman numeral 3, we said a square root times itself is the same number. A square root times itself is the same number. Okay? So guess what? On the bottom of our fraction, right here, square root of 3 times square root of 3 is 3. Okay? The square root goes away when you multiply it times itself, because you're essentially squaring it, which is the opposite of square root, which cancels it out. So take my word for it. Whenever you do this step and you square root 3 times square root 3, it'll give you just the number 3. Okay? Now, the denominator, the bottom, has no square root. Yay! Okay? So, the only other thing you have to do is ask yourself, is the square root able to be reduced? So is 3 able to be reduced? No, it's prime. And then you want to think about this fraction. Can this fraction be reduced? Does 2 over 3 get any smaller? No. So it's done. Now, you might think that's an ugly fraction, but we'd rather have an ugly fraction with a whole number on bottom than a fraction with a square root on bottom. Okay? So, I'll do 7 and 8 with y'all, and I want y'all to try 9 and 10. So on number 7, on the bottom of number 7, right, you see a square root of 2. So, how do I get rid of a square root of 2? We're going to multiply by the square root of 2. Okay? So again, if I have a square root on bottom times the exact same thing, and if I do it on bottom, I'm going to do it on top. Okay? So, what's 8 times the square root of 2? Yes, student that I'm not going to name on my video. What is 8 times the square root of 2? Nope, it's 8 square root of 2. All right, we have no cameos on my YouTube channel, right? So anyways, 8 times the square root of 2 is 8 square root of 2. You got to know that. Whole number, square root, put them together if you're multiplying. Now what about the bottom? Generic student over here with no name. What's the square root of 2 times the square root of 2? 2. Okay, the square root goes away. Very good. All right, male or female student up front, whoever they are. All right, 8 over 2, that fraction, does it reduce? It does. What is 8 divided by 2? 4. So, this actually equals 4 square root of 2. Do you see how you might have extra steps involved where you need to reduce a fraction or reduce a square root? Thank you for your affirmation, student, in the back. All right, number 8. There's a square root on the bottom, square root of 3. What do I got to do? Times the same thing, square root of 3. And if I do it on bottom, I do it on top. So, student, what's 9 times the square root of 3? 9. You say. 9 square root of 3, okay? So 9 square root of 3. You just put them next to each other. They're buds, okay? On bottom, square root of 3 times square root of 3? 3. Very good. Is that it? No? No? What do we got to do? Okay, 9 over 3 reduces to 3 square root of 3. Okay, so just like last time, I'll give you a couple minutes. I want you to try the bottom 2. Show me how smart you are, students. We back on this. So on number 9, what do I multiply the top and bottom by? All right, square root of 2. Okay, so times square root of 2 on top and bottom. What do we get? 7 square root of 2 over 2. 7 over 2 doesn't reduce, right? You gonna answer this one? So what do I multiply by? Square root of times square root of 3. Square root of 3. All right, so on top, what do I get? 8 square root of 3, and on bottom I get 3. Does 8 over 3 reduce? Nope. So 8 over 3, leave it, right? So these are my answers. These are all solid. And now we're going to the back side, so you can flip it over. Now we're going to do adding and subtracting radicals, okay? Okay, now at the top, I want you to write this. We have to remember how to combine like terms. If you know how to combine like terms, this is just another way of combining like terms. All right? So, addition and subtraction. It says when adding or subtracting radicals, you must use the same concept as adding or subtracting like variables or like terms, okay? Here's what we mean, okay? Look at letter A. 2x plus 3x. Whenever you're adding, you can only add like terms, and you're only going to add the coefficient, the number in front, right? So 2x plus 3x is how much x? 5x, right? And if you didn't use the word x, it would make sense, right? 2 apples plus 3 apples is 5 apples, okay? It's things, okay? So what about letter B, 7x minus 5x? 2x, right? We're just subtracting the coefficient, right? Now, what's weird about letter C? We have 2 different variables, right? So what do? Do we make it 8x, 8y, 8xy? What do? Okay? Well, you can only combine like terms. These are not like terms, so we don't combine it. We're going to leave it exactly the way we started. Very good, student. So, 5x plus 3y is 5x plus 3y, right? Let's replace x and y with apples and bananas, right? If I had 5 apples plus 3 bananas, they don't become 8 apples or 8 bananas or 8 banapples. It doesn't work that way, right? So again, if it can't combine, it doesn't combine. So we're going to use the same concept for square roots, okay? So instead of an x, now we have a square root of 3. So if I have 2 square root of 3, 5 square root of 3, how much square root of 3 do I have now? 2 plus 5, 7. And here's the important part. The square root stays the same. I'll say it again. When you're adding and subtracting, the square root number stays the same under the radical. All right, what about this one off to the right? What number belongs in front of this square root? A 1. You don't have to write it if you know it, but it helps you remember. So what is 4 square root of 3 plus 1 square root of 3? 5 square root of 3. Very good. So same idea, just now we're going to subtract. Everyone looking up here? So 5 square root of 7 minus 3 square root of 7. 5 minus 3 is 2 square root of 7. The square root stays the same. 2 square root of 3 minus, this should be 1 square root of 3, is 1 square root of 3, or just square root of 3. Okay? Now, hopefully that's not too bad, pretty straightforward. So I want you to take that, and I want you to try Try 1 through 8 down here. But I'm going to, real quick, before you get started, be careful on number 4, because the square roots are different. We talked about how to do that, right? Be careful on number 5, because they're not all the same square root. And I'm going to help you do number 9 real quick, because some of y'all might think number 9 can't be done. Now, look at number 9. They're different square roots, right? Can you add them together right now? They don't match, right? Square root of 2, square root of 18, can't add them, right? But we learned on the very first page that we can do what to that square root of 18? Break it down. We're going to do the factor tree. We're going to reduce that radical. So let's do that real quick. 18 breaks down into 2 times 9. 9 breaks down into 3 times 3. And that's it. Do I have any pairs?
Yeah.
Pair 03, tragedy, right? So what goes out? The 3. What stays in? The 2. So above it, I'm going to rewrite 3 square root of 2. Now let's rethink this problem. Can I add those 2 square roots? Now I can. So you see how you had to reduce first? Now we can add them up. I have a 1 square root of 2 plus a 3 square root of 2. That gives me 4 square root of 2. So that's kind of tricky. So when you get to number 10, think about number 9. Okay? So try 1 through 10. If you get stuck, obviously, we'll help you out. All right. So let's go over these answers. Number 1, 2 plus 4 is 6, square root of 3, right? Number 2, 8 minus 4 is 4, square root of 5. Number 3, 3 minus 1 is 2, square root of 2. Number 4, what's wrong with number 4? Different square roots. Can we combine them? We cannot combine them because they're not like terms, so we're going to just rewrite it. Only combine it if you can, and you cannot right there. Number 5, it's kind of similar, kind of different. I have 2 of the same square roots, so I can combine those. So this is going to be 2 minus 3, which is negative 1, square root of 3. And I'm going to bring down that minus square root of 5 that I cannot combine. And that's it. Only combine what you can. Number 6 is going to be 8 minus 7, 1 square root of 2, or just square root of 2. Number 7, 3 plus 4 is 7, minus 8 is negative 1, square root of 2. All of the square roots were the same, so it makes sense, right? Number 8, 10 minus 5 is 5, bet. And number 10, there we go. Number 10, 27 breaks down into 3 times 9. 9 breaks down into 3 times 3. So what's my reduced radical going to be here? 3 square root 3. So I'm going to rewrite it up here. What is 3 square root of 3 minus 1 square root of 3? 2 square root of 3. Okay? Just to make sure this whole packet's done, check your answers for the other ones. Okay? We talked about the answers for number 4 here and for 5 here. So, real quick, make sure you have these answers. This was 12 square root of 25, which breaks down into 5 times 5, which would be 12 times 5, which is 60. 1 times 4 is 4. 2 times 3 is 6. That does not reduce. And then down here, these were pretty easy. 3 and 37.